Welcome everyone. So in this video we're going to be looking at set notation as it relates to probability events. So what we want to now do is we want to be able to interpret the demands of the question and diagrammatize and then apply the relevant formula or intuition to the problem. So here we're told that let u equal all positive whole numbers less than 10. So that U means the universal set. So it's a set of all of the numbers that we'll be considering for this question. So if we want to spell it out, U is equal to all positive whole numbers less than 10. So that will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So your whole numbers, of course, are numbers, integers, numbers without any fractional or decimal parts. And we want positive whole numbers. So we're going to exclude 0. So 0 is a whole number, but not a positive whole number. Now here we're going to have A to be the set of prime numbers, and it will be prime numbers that are contained in the universal set. So we're going to start from 2, 3, 5, and then conclude with 7. And then B will be the set of even numbers. So that would be 2, 4, 6, and 8. So all of A and B are subsets of the universal set. So we can take this information and then draw a Venn diagram. All right, so that will be, so a Venn diagram will be two overlapping circles. So here we can label that as A, label that as B. We always want to start with the overlap. So that's the number that is contained in both row A and row B, which is 2. Then fill out the rest of A, that would be 3, 5, and 7. Then fill out the rest of B, 4, 6, and 8. Check now that you have accounted for all of the numbers in the universal set. If we have not accounted for all of the numbers in the universal set, we will fill out the blank space outside of the two circles that we have drawn, but inside of the rectangle. So 1, we have 2, 3, 4, 5, 6, 7, 8, and then 9. And that would complete the drawing of the Venn diagram. So now let's have a go at the questions in front of us. So part A asks us to solve for the probability that A will intersect with B. Now remember that A intersect B, and that symbol stands for intersect. It is the overlap, that which is common to both A and B. If we look at row A and row B, then that which is common is the number 2 as drawn here. And we ask ourselves the question, how many elements are in the overlap? There's only one element in the overlap. So it's the number of elements that satisfy this divided by the total number of elements in the Venn diagram. So this will be equal, so the number of elements in A intersect B divided by the number of elements in the universal set, and that's 1 over 9. And that would be how we would complete part A. Part B, we're looking now at all of the elements in A, all of the elements in B, without any repetition. So we're including everything in A and B, but not repeating any element. So that means that we'll only include the number 2 once. So if we do that, we're now going to count. So this requires us to count the number of elements in the union. So that symbol means union. So we are counting all elements in A and B without repetition, and then divide that by the number of elements in the universal set. So 1, 2, 3, 4, 5, 6, 7. And that would conclude part B. In part C, this symbol means the complement of A, or it would be read as the probability of A complement. Another way of reading it would be the probability of not A. So the probability of A complement is the probability of observing everything that is not inside of A. One strategy would be to cover everything that is in A and then count what is not in A. So that's 1, 2, 3, 4, 5. So this would be 5 out of 9. And it would be the number of elements that are not in A over the number of elements that are in the universal set. All right. In part D, you're being asked to find the number of elements that's not in A, but in B. So the number of elements not in A and common to B as a fraction of the universal set. So the number of elements not in A, so elements not in A would be 1, 9, 4, 6, 8, but they must also be in B. So that means that we're looking for 4, 6, and 8. So there are 3 elements, and then that is 3 out of the entire universal set. So this is going to be 3 out of 9. We can leave it as 3 out of 9, or we can simplify that to 1/3 if we prefer. All right, the probability of A complement and B complement. Now, do be aware when you have something like this, we could factor out the complementation symbol. So this is the probability, and think of it like when you factor out a negative sign, all right? It changes the sign of the operation. So intersection now becomes union, and the factor complement sign is here. So the probability of A complement intersect B complement can be written as the probability of A union B complement. All right. So this is a useful result, and then we can invoke so we can look at what is the complement of A union B. Everything outside of A union B, which is 1 and 9. How many elements are there? There are 2 elements. So this is equal to 2 out of 9. So writing it that way may be a more useful or efficient way of getting to the answer. All right, in part F, we have A complement union B. So A complement is 4, 6, 8, 1, and 9. And union B means that we include everything else that's inside of B, which is the 2. So 1, 2, 4, 6, 8, 9. So that is 1, 2, 3, 4, 5, 6. So this is going to be 6 out of 9. So notice my approach. My approach has been to use a cover-up method strategy in order to sort of fix the elements that satisfy the demands of the problem. So A complement union B, A complement, I covered A, and that allows me to see what A complement is, which is 1, 4, 6, 8, and 9. And then union means that I must now combine it with all of the elements in B, but not repeat any of the answers that I previously stated. So that means that I only have 2 that remains to be included. All right, so hopefully that was helpful in sort of laying the groundwork for the symbols and the methods that we'll be applying in the videos to come.